Okay, can you guys hear me?
Yes.
Are there any, we have a little bit of time before we get started, so are there any questions before we get started about homework or previous lectures or other things? Yes, there was a question in the log. It says, can you define what a strike price is? Well, yes, I can. Let me see if I can do it. So, okay. So when you're looking at, so we have just some questions. So when we're looking at a derivative, it has a payoff. So derivatives, we have payoffs. And there's a function. So there's a function here, you have payoffs. And right, this is at the end, you only have 2 time points, so time 1 and time 0. So you have payoffs at time n given by this function f. So this is going to be f of s1, right? So these are random. And so a particular class, so if you look at options, then you have a put. So there, your function is going to have the form, if it's a put, you have the strike. K here is a constant, and this is called a strike. If you have a call, you have a different function. So it's going to be x minus k positive part. And again, k is a constant, and k is called the call strike. Right, so when we talk about strikes, k's, what is meant is that this function that gives you the derivative's payoff is given in terms of this constant k. And that constant k is called the put strike and the call strike. Yeah, does that make sense?
Is K related to the price of the option at all?
Yes. Yeah, different Ks will correspond to different puts and different calls, right? A bigger K is going to give you a bigger payoff for the put. A bigger K is going to give you a smaller payoff of the call. So the option price depends heavily upon what K is.
But the option price isn't exactly K, or is it?
No, it's
Is it
not.
K?
No,
Oh, it's not K. Okay.
no. I mean, if it was that simple, we would talk about options for like 2 minutes, right? The price of the put is K, and then done.
Yeah.
There will be no need to take a course like this one. That is way too simple. This is not how it goes. The K matters for the price, but it's not going to be the case that there's such a simple mapping into what the price of the put is. You see, what's happening is that K controls the payoff at time one. But what you're interested in is the price, not at time one, but at time zero. So you need a mechanism that will take these payoffs that you get later and move them back in time, or move them forward in time. And that mechanism is non-trivial. Then there was a question for regarding the homework. We need to write out. Do we need to write out proofs for question in problem 2? Yes, you do. Yes, you need to write out how you get the answers that you get. Okay, so before we start, we're going to be spending a few minutes talking about. Well, I'll lead out to Mrs. Yap. I'm not sure how this stuff here works, so I'm assuming that can you share the screen on your end?
Yeah, I can, but I don't need to
You don't?
share
Okay.
anything. I can just talk about it.
Okay.
Yeah, hi. So thanks for letting me come and talk to your class. But I just wanted to advertise an organization that I'm a part of to all of you. So my name is Corinne, and I'm a math PhD student, and I'm one of the organizers of the Rutgers chapter of the AWM. That's the Association for Women in Mathematics. The AWM is a national organization that's devoted to supporting women and girls at every stage of their journey through mathematics. Our chapter is open to all students and faculty at all stages, so that includes graduate students, that includes undergraduates. You don't have to be a math major or a math minor, even just you're taking a math class, so you're all of you are welcome to join the chapter. Even though it's an organization whose mission is to support women, the membership is open to anyone of any gender or gender expression. While we kind of plan our events with the focus of encouraging women and doing outreach to women in mind, a lot of our events are just good things for any student in math to join and hopefully are fun for a lot of different people. So I'll give you a few examples of things that we've done in the past. We often have lunch with invited seminar speakers who come to speak at different math department seminars. We've had kind of professional development workshops. Like last year, we had one for graduate students to kind of develop their 3-minute elevator pitches. If they were asked to describe their research to someone who has no idea what it is in 3 minutes, then how in the world would you do that? So we kind of practiced how to write those and how to give those to guest faculty members who are there. This semester, we're especially planning to focus more on undergraduate-centered events. So we are holding later in the semester. One example is a panel and workshop where you're hosting jointly with RUMA, the Rutgers Undergraduate Math Association, about applying to REUs and workshopping application materials to summer research programs and other similar summer internships and things like that. And lastly, we also just have like, casual events like lunch every other week to just chat and get to know each other. So especially if you want to find out, what it's like to be a graduate student, or you want to meet some graduate students or faculty in the department, this is a great opportunity to do that. So let me just drop in the chat a link to my website where you can see a more detailed description of the events that we've done in the past. Let me type that here. It's just a page on my website. And if you'd like to sign up for the mailing list to receive news of upcoming events, you can email me at corinne.yap@rutgers.edu to sign up for the AWM mailing list. We are planning our first meeting as just kind of a meet and greet to kick off the semester next week. So if you join in the next few days, you'll receive news of that, and you can fill out a little scheduling poll for us to plan which date we're going to meet. All right, so that's my spiel. I guess I can answer, you can feel free to email me with any questions, but I guess if you have any quick questions right now, I'm happy to answer those. All right, great. Well, yeah, as I said, feel free to email me about anything or any questions that you have. But thanks for listening, and thank you, Professor Larson, for allowing me to come in and advertise.
Maybe I'll just say one thing. So this is something that I kind of hold perhaps more dear to my heart than many others. My wife is a mathematician too, and she's also at Rutgers. And it is really, so when you have the undergraduates, there are lots of females. Then you move into the PhD program, and there are less. Then you move into the postdoc level, there are less. Then you move into the tenure track system, there are less. Then you move up to the faculty level. In terms of research, there are less. So there's this, the females, they just disappear more and more and more, and it becomes more and more man-centered up top. And given that, there's absolutely no indication that somehow men are more able to do research in math. The loss that the math community faces because we lose females as we move up, it's huge. It is the Rutgers math department in terms of researchers, active researchers, has females, but not very many. But there are other places. I was at Carnegie Mellon before coming to Rutgers, and there was one female researcher in the entire department. And there are many reasons for this, and there are all kind of like special reasons for why that individual has this set of circumstances and then drops out and so on. So it is really important to have a community around yourself. And so personally, I would very much like to foster and try to get more and more people interested, but in particular females interested in it. And it is a non-trivial task. So I'm really happy that we have a group that is trying to foster this kind of environment. And so if it's something I can do to help, just please reach out. I'm happy to do it. I'm also happy my wife, she's pregnant now. And of course, this is one of the things that is different between men and women. And this is something that can be very complicated if you are on a research trajectory, like how am I going to have kids in the middle of all of this? And so if some of you have such concerns, I mean, my wife she had 2 kids while she was a PhD student. So I mean, there'll be somebody there to reach out to that has been through the ringer in all of this. Yeah, so that's just a personal side. Sorry.
Yeah, thank you so much for saying that. I think, yeah, one of our main goals is to just, foster inclusivity and create a supportive environment within the math department, and to create a community where, we can talk about these things and really figure out like, what is it that we in the department can do to increase retention and to really encourage women to stick it out their math. Yeah.
Yeah. So here, I don't mean to say that women is the only minority that is missing. I think
of course, yeah.
There are, like in terms of the African American population, there are very, very few researchers with that background, and this is a huge loss for the math world, right? Because all these people have all these ideas, and they never get like fostered and developed, and as a consequence, we are still stuck on problems we don't know how to solve. Whereas if we would have somebody that has a different perspective, have a different background, have different ideas, whatever, you can bring it in. Diversity is the only way you're going to make real big progress. You're not going to make really big progress by having a bunch of guys that have the same ideas. It is not going to lead to like huge leaps forward. And it's just not how it is. And math is no different than it is in many other disciplines. You need different people with different backgrounds, having faced different kind of challenges in their life, come together, and this is when really big strides can be made. So yeah, I'm really glad that you guys are doing it. Okay, enough about all this.
All right, thank you so much, and I really appreciate what you said.
Okay.
All right, have a good class.
Yeah, you too. Okay, so back to 485. Yes, so we had, I'm going to try to see if I can start these lectures a little bit on the earlier side. I know some of you are having don't find the hours for the office hours to be particularly convenient. So I'm going to try to see if I can show up a little bit earlier, 10-15 minutes, maybe take a question or two before the class starts. So I'm going to try to do that. There's a little bit of, there are many moving parts around this time in a household with small kids. So if it works, I'm happy to do it. If I can't get it to work, then I apologize. Anyway, we are talking about a one-period binomial model. So, so we're looking at a one-period binomial model. And okay, so remember what the inputs were. The inputs were, so we have a bank. Starts out with this value, and this is very often just taken to be $1. And then what characterizes the bank is the way that the price is in the next period has no randomness. There's only one possibility, and it's going to go up to whatever it was times 1 plus R. Right, so if it starts out at $1, this is just going to be 1 plus R, in dollars. So that's what sets the bank apart from the stock. The stock, on the other hand, starts out with is 0, and then it can take, in a binomial model, it can take two values. It can either go up or it can go down. If it goes up, it's going to go up with a multiplicative factor, u. And if it goes down, well, we're going to have u times d. We're going to have S0 times d. So this here is at time 0, this here is at time 1, this here is at time 0, this here is at time 1. So that's the input that we have. Then we have a no arbitrage condition. That means we merge the two pictures and see how that looks like. So we merge the two pictures. So if we are imagining that instead of starting out here at 1, we're going to start it out at S0. And then we can merge the two pictures so they have the same starting point. So then I'll have, this would be my S0, and then this would be S0U and S0D. And then I want to merge this thing in together with this picture. Okay, so I'm going to start out here, instead of 1, I'm going to start it out at S0, so then I have to multiply S0 up here. So then I'll go into S0 times 1 plus R. And we talked a lot about this picture last time. So no arbitrage means that the bank account, that leg on the bank account, has to sit strictly in between the two legs of the stock. So no arbitrage, it means that U is bigger than 1 plus R is bigger than D. And very often we will take this to be positive. So we take D to be positive because that ensures that stock prices are positive. Okay, so that's a condition. This is our no arbitrage condition. We will always work under this condition. And sometimes you'll see. Sometimes you'll see. What will you see? You'll see something like R is equal to 0. I have seen in the past that some students might be thinking that when R is equal to 0, it means that there's no bank. We still have a bank account. We still have the middle leg here, even though R is equal to 0. What it means is that that middle leg is just completely flat. It's horizontal. So this here, we still have a bank. Still have a bank account. And another property you often will see is that this U times D is equal to 1. This is at least what the textbook favors. So very often you'll see U is equal to 2, and then D will be equal to, well, 1 over 2, half. But this has nothing to do with no arbitrage. So this here is the no arbitrage condition, but sometimes you'll see these further specifications. Okay. Are we good so far? Otherwise, now is a good time to say, stop, do something else. So we've been over this in a few lectures, and there have been comments like, there should be something about a probability here. There should be probabilities in here. And it's true that we do have probabilities in this model. There is an underlying random variable. So the underlying randomness, it comes from this variable psi. It comes from this psi, which can take 2 values. We have a conflict, so it comes from psi being U. If you have a T is for tail, so this is probably a D. So if you see tails or if you see heads, actually the underlying randomness is this random variable psi. And the way we want to write this psi is it's a map that goes from its domain is going to be well, it'll be something that has H and T in it. And then it takes values in its codomain, and the codomain is U and D. And so the underlying assumption is, so our standing assumption is that if I look at the probability that psi takes the value D, then this is something between 0 and 1. And consequently, if I look at the probability that you get U, this is also a number between 0 and 1, strictly between 0 and 1. But we don't specify, but the actual value of this guy, we could call him P, the probability of up. But the actual, the specific value of this constant here, other than being somewhere between 0 and 1, is irrelevant. Irrelevant. Right, so it could be it could be P equal to half, P equal to a quarter, P equal to a third. It doesn't matter. It doesn't matter for derivative pricing. And this is perhaps what's a little bit confusing or a little bit surprising, that that particular probability plays no role in what we've done in the last couple of lectures. Okay. And you can go back and look through the videos, and you can go back and look through your slides, and nowhere is this value P appearing in the formula for the derivative price. Okay, so what I'm going to do now is I'm going to talk about probabilities, but you're not going to be these probabilities. I'm going to talk about other probabilities. Okay, so this next part here, this can be a bit challenging. So let me try to get us through it. There is something called risk neutral probabilities. Risk neutral probabilities, and they're denoted by this P tilde and Q tilde, which is 1 minus P tilde. Right, so they're not the same. These ones here, they're not in any possible way the same as this P here and this 1 minus P. Right, so they're not the same. These are different from P and 1 minus P. So whereas these guys, they don't matter, what we're going to see is that these guys up here, they matter quite a bit. So how does one create these risk neutral probabilities? And there are many ways to introduce them. And let me show you how I think about them. All right, so we have our tree. We have this tree here. Let me make a copy of this on the next slide. So we have our starting point, we have our input. What's that tree? So this was S0. We had S0 times U. We had S0 times 1 plus R. We had S0 times D. This was at time 0. This was at time 1. So now we're going to come up with a crazy idea. We're going to introduce discounted prices. Write that down here. So discounted prices. A fancy way of saying that is that the numeraire is the bank. Okay, so those are long words that are complicated to understand. So what does it mean? Well, discounted prices, here's what it means. You take the stock and you define something with a tilde on top. So this here is a new set of prices. So this here is a definition. This is my new stock price. And what I'm going to do is, I'm going to define this as the original stock price. And then I'm going to divide by the money market account, that initial value. And if we say very often this is taken to be 1. So if you take this one to be 1, then you're just going to get this 0. The other one is then going to be the stock price at the end. And the way we're going to do that is by taking the stock price. So that's going to be my S1 that I have out here. This guy is S1, this guy is S1. And then I'm going to divide by the money market account at time 1.
Just to clarify, is the money market account how much money you have in the bank? Or is it like borrowed money?
No, it's the price. It's the price of the bank account. The price of the bank account has this. It has the value of S00 at time 0, and it has the value of S00 times 1 plus R at time 1.
Okay, gotcha.
It's the price process for the bank account.
So we're thinking of the bank as like we can buy stock in the bank too.
Yeah. So what's the difference between a bank account and a stock? Well, so in this picture, the difference is that you have 2 possible values for a stock and you have 1 possible value for a bank. There are many other differences between bank accounts and stocks. A fundamental difference between a stock and a bank is that if you own a stock, then it's not necessarily the case that somebody else is short the stock. Like, stocks are typically in positive supply. Right, so if there's 1 million shares out there of a stock, then we can all own stock. And it's not true for the bank. The bank is in 0 supply. If somebody is long a bank, somebody else is going to be short. There's something about ownership. Typically, when you own stock, you get to vote on the company's meetings, right? But if the company goes bust, the debt holders, they get served before you get served. So it might be that you get to vote, but you don't get paid before the debt holders get paid. And this is different for a bank. Right, so there are fundamental differences between these 2 securities. In this class, the way I treat them currently is that you have 2 securities that have given price processes. And you can go long and you can go short as much or as little as you want in both of them. Okay, did that answer your question?
Yes.
Great. Okay, so let's push on. So this here is my new set of prices. So how does that look like? I'm just going to keep my life a little bit. Maybe I'll keep it a little bit simpler. Maybe I'll keep it a little bit simpler just to look at the formulas. So let's consider the case as an example. Let's just consider the case where the initial point, the initial stock price is the same thing as the initial bank account price is equal to 1. It's probably not such a big deal. We can presumably scale everything so that this happens. Then, if that's the case, then how would I look at my discounted prices? Well, I'll take the previous picture. So now I'm just making it a little bit easier, putting a 1 here, putting a 1 here, putting a 1 here, and putting a 1 here. Okay. So what will I get? I'll get my S tilde is 0. Okay, so that's going to be the first one. The initial stock price in the case where I normalized everything to be equal to 1, then that would be 1, and then I'll have my values here. And so what's going to happen is that upstairs I would have I would be able to write out that this one here is S1, right? So this is divided by S00 times 1 plus R. So up here I would have U divided by 1 plus R. Right. Again, I'm just simplifying here by taking S0 to be 1. Otherwise, I have to have an S0 here. The flat one the flat one, I have 1 plus r divided by 1 plus r, so this is a 1. And the downstairs one will be d divided by 1 plus r. So I took the picture we had and I just divided through with 1 plus r everywhere. Okay, so then what? So now you can see this is almost like, this here is like a zero interest rate. Because this is flat. This, when would this thing here be flat? This would be flat exactly when r is equal to 0. Right, so this is what is meant over here, that the numerator is the bank. We measure everything in terms of bank prices. That's the numerator. The numerator means whatever we're measuring in. There are some questions here. Does it say numerator? Yes, this is what I'm writing here, numerator. Okay. So why on earth do this? Well, we're getting closer to these risk neutral probabilities, and let's see what we want to do. So if I'm looking at wealth, we had that one last time. Right, so the wealth is in these discounted prices. I'm going to put an X tilde on top of it. The wealth was what? The definition of wealth was, well, you look at the number of bank units times the bank price. Okay, the bank price is at time 1 is equal to a 1, so we have a 1 here, plus, and then we look at the number of stocks that we have times the stock price, right? And the stock price was this S tilde 1 here. Okay, so I can expand this by saying that this is 1 times 1. I can forget about the 1. Here I'll have delta, and then I'll have S tilde minus S tilde 0. So now the equality sign is not true, and I'll have to add up delta times S tilde 0. Okay, so now the equality sign is true again. Right, and if I take these two and I combine them, this is the number of bank units times the bank price, plus this is the number of stocks times the stock price. That's going to be my initial wealth. So that's my X tilde times 0 plus this difference. Okay. And so what we want this thing, so the goal is to create what's called arrow de Breuil securities. And what are arrow de Breuil securities? These are the ones that look like the following. So they have two payouts, they have two values, so it can either be $1, I shouldn't call them dollars, this should be 1, 0, and the goal, of course, as it always is, to figure out what the price is at time 0. So this is the up. This one here is the up. And these arrow de Breuil securities are called AD. This is up AD. And then we're going to have a down AD as well. And this one here is a down AD. And the question is, what is this initial value? Okay, so we're imagining that we can trade in the bank account that has a 0 interest rate, and then you can trade in the stock that goes from 1 up to U divided by 1 plus R, or it goes down to D divided by 1 plus R. Okay, so what does it mean to trade? Well, it means we buy some units of the bank and we buy some units of the stock. And the goal is to create these two deltas such that the wealth process at the end is 1 and 0. Create another pair such that the wealth at the end is 0 and 1. And we did that last time. So we do the same thing. So instead of a call option, we just have 1 and 0, 0 and 1. If you think back to what you guys were doing what we were doing last time was we had this linear system of equations. And we're trying to find solutions to it. So what I'm doing now here is I'm finding bases. This is like expressing, if you have a basis in R2, you need two elements. And you can express any other vector in R2 in terms of linear combinations of these two particular elements. So that's what we're doing. So we're finding these the prices of these basis elements, and these basis elements in quantitative finance are called algebra securities. And so how do we do it? Well, we do as last time. We need to solve. What do we need to do? We need to look at these equations that we had here. We want x1. We want x1 to be, well, it was either 1 or 0. Okay, so that's what I want x1 to be. And then I have delta 0 plus delta, and then the price of the discounted stock. The discounted stock was u divided by 1 plus r. So that was in the up state. We do the same thing in the down state. Delta 0 plus delta times d divided by 1 plus r. So just as last time, we have two equations and two unknowns, and now we're going to go ahead and solve it. So this here is the same thing. If I did it correctly, this is the same thing as saying that delta is 1 plus r divided by u minus d, and that delta 0 is minus d divided by u minus d. And then we find our x0. So then our x0, x tilde 0, this would be, well, the number of units times the discounted money market account price. So this would be minus delta over u minus d times the initial price of the bank account. That was a 1. Plus, then I'll have the number of shares. This is 1 plus r divided by u minus d times the initial price of the stock, which is also a 1. And so I think we can combine these. We get u minus d downstairs. And what else do we get? We get upstairs, we'll have 1 plus r minus d. And that's my initial wealth. That's the number that would have to go out here in the question mark. So out here we will have 1 plus r minus d divided by u minus d. Okay.
Professor, which thing are you substituting in to get wealth 0 tilde?
Well, what is the definition of your initial wealth? The definition of your initial wealth would be the number of units that you have in the bank times the initial bank price plus the number of units you have in the stock times the initial stock price.
Gotcha. Okay.
Right. So here, this quantity here is delta 0. This quantity here, this was S tilde 0, 0. This quantity here, this was my delta, and times the 1. This thing here was just my S tilde 0. I'm just making my life a little bit easier by normalizing the initial prices to be 1. This is not a big deal. Okay, so what is it we know about this quantity? Well, we have this no arbitrage condition from one of the earlier pages. Right, we know this is true. We know this is true. So in particular, I know that 1 plus r. I know that 1 plus r is bigger than d. So in particular, I know that this thing here is positive. This is a no arbitrage condition. What else do I know? Well, I also know to figure out what the value of the down security is. So remember last time when we were talking about how one creates these, we would have a picture that would have like a hat, and then the question was how would we form portfolios or put calls, forward stocks and the likes to create this particular diagram. So now we're doing the same thing. What would be the price of this one here? Well, if I take a portfolio of these two, so I buy one of this and I buy one of this, the portfolio of these two would then have a payoff that would always be 1. Right? If I buy one of these and I buy one of these, then at the end, one is paying out $1 and one is paying out $1 in the opposite states. So if I hold a portfolio of these two, there's no difference between that portfolio's payoff and the payoff of the bank account. And so therefore the initial prices must be the same. And so what's the initial price of the bank account? Well, that was $1. And that means that the sum of these two, the price of one of this and one of this at time 0 would have to be 1. And I already figured out what one of them is worth. So then the other one, there's no way around it. It has to be 1 minus 1 plus R minus D divided by U minus D. So what do we get? So we have a number here that's positive. We have another number that is positive. The add up to something that's equal to 1. Okay, so that means that individually, each one of them must be less than 1. So those are our risk neutral probabilities. So we define P tilde to be this quantity up here, 1 plus R minus D divided by U minus D. We define Q tilde. This is going to be that 1 minus we had up here, 1 plus R minus D divided by U minus D. And we can simplify this. So what would it be? You put U minus D on the same. So then you have U minus D here, minus minus, this is a plus, this is U minus 1 plus R. So now what we know is, so we know now, we will have that P tilde is a number between 0 and 1. We will have that Q tilde, this is a number between 0 and 1. And we'll know that the add up to 1. So the probabilities. Okay. Let me try to do a poll this time and see how that went. Risk neutral probabilities. Risk neutral probabilities. this is the first time that you guys are seeing risk neutral probabilities, and these risk neutral probabilities, they're going to be things that will appear in many of your courses later on. So we need to get a good grip of them. So do it again or do it a better problem. I agree. I agree. Let's talk more about this. So let's do an example. Page 7. So we've had the example before where what would we do? We would do we would go from $4. We go from $4, and then we will go up. We go down. We go up to, my note says 6.4. And you go down to 1.6. And the bank account would sit. I think the one that we had was a clean piece of paper. The one we had was, we go from 4 to 8, or we will go down to 2. And the bank would sit in here. It would go from 4 to 5. So then we just rescale everything. We rescale everything by the dotted line. So if I rescale, so this here was my S and S naught. I will rescale everything by the dotted line. If I rescale everything by the dotted line, I would get what would I get? I would get, so say you're still out here at 4, and then we'll go up to 8. So now we'll have to do 8 divided by we have to do 8 divided by the interest rate would be what would it be, 25%. So we will go from 4 up to 8 divided by 1.25. If I've done this correctly, I should get 6.4. And the same thing here. So this here would be my 4, and then this one here would be 2 divided by 1.25. If I don't write, this should be 1.6. Right, so this is my tilde world. This is the discounted stock price, which was equal to S divided by S naught. And of course, if I look at the discounted, this is way overkill. If I look at the discounted money market account by itself, it's of course going to be 1. Right, so that's the flat line you see here. So what I'm interested in is, creating error-averse securities. So there are 2 of them. We got the up and we got the down. So the up one, I'm going to put P tilde as the initial value. The up one is going to pay out $1. No, so it's not the right dollars here. Up is going to pay 1. Down, I should pay out 0. And likewise over here, I'm going to put Q tilde as the initial price. And so here I'll get 0, and here I'll get 1. So what did I do? I took the stock price. This is an example we had last time, and I formed the discounted price system. The discounted price system is nothing else than just taking the original stock prices and dividing by the money market account. Right? So at time 0, we're just pretending here that the initial money market account starts out at 1. Right? So 4 divided by 1, okay, this is still going to be 1. And then at time time, the later time, you'll take 5 divided by, well, there will be 4 times 1.25, and so you're going to get 5 divided by 1.25, this is exactly 4. So that was the first one, and then you do the same thing for the stock. You take 8 divided by 1.25, forming these prices. And so what's the value of what's the value of P tilde and Q tilde? Well, you set up, you got to solve. So for this system here, what we would have to do is you would have to buy bank units. Okay, bank units you start at 1, so they pay out 1. And the other ones, the stock will be delta units of the stock, and then at the end it'll pay out 6.2, 6.4, and you have to get the 1. So the same thing here, but instead of 6.4, you get 1.6. So that's one system to solve. This system over here, the only thing that changes is the right-hand side. I'll have a 0 and a 1. I'll have a 0 and a 1, and so up here I'll have delta 0 plus delta times 6.4. And down here I'll have delta 0 plus delta times 1.6. Well, I got 2 systems and 2 equations. I solve them, and I'll get P tilde and Q tilde. How will I get that? I'll get this here as saying that this is delta 0 times the initial price of the bank account. This is a 1, and then plus delta, whatever the solution is, times the initial stock price in the discounted market. This is a 4. Right, and likewise over here, you would get this one as delta 0 plus delta times 4. Right, and the key thing to remember is that if I look at these 2 diagrams and I just add them up, if I add up the 2 payoffs, like if I take these 2 diagrams, this is a note. If I take this diagram plus, and I take this diagram, do the other way. So this is a 1, this is a 0, this is a 1. What I'll get is, I'll get 1 and 1. Right, so the price of this diagram, this is going to be exactly the P tilde price plus, this is going to be Q tilde, and the price of 1, because you're always getting 1, we know that this is the price of 1, and this is at time 1. Price of getting 1 at time 1, well, you know what that is in this discounted market. Because the money market account is flat, getting $4 at the end is the same thing as getting $4 at time 0. So you know that P tilde and Q tilde, they must sum up to 1. Okay, and on the other hand, you're looking at the diagram, P tilde is the value of getting either 0 or 1. Okay, so no arbitrage should tell you that P tilde is going to be strictly positive. It's going to be strictly positive, and it's going to be strictly less than 1. And it has the same properties true with Q. Q tilde is going to be strictly positive, it's going to be strictly less than 1. And you also know that when you add them up, you're going to get 1. In this particular example, you get actually the same, but that's rare. So there's a question in the chat. Let me just read the question. Just to confirm, it's the same as buying the bank because you buy into, yes, that's exactly the same. So that's correct. So there's no difference between a portfolio. There's no difference between a portfolio that consists of one of the up and one of the down and the bank because you have the same payouts. Therefore, you'll have the same initial price. So what is this thing good for? Well, I mean, so what is this thing good for? But if you look at a call, or was it a call we did? We did a put. So now what? So how would you price? So price other payoffs. If I were to price, say, say a payoff that would look like 5 minus 8 positive part divided by say 1 plus r. If you were to price a payoff that would look like 5 minus 2 plus divided by 1 plus r, how would you go about doing that? Well, this one here would be 0. And this one here would be, if I've done it right, this would be 5 minus 2. 5 minus 2 is 3 divided by 1.25. This is, how would we price such a payoff? Well, you would buy, how many of the up securities would we buy? We would buy 0 AD up. And how many would we buy of the down ones? We would buy 3 over 1.2 of AD down. So the net price would be 0 times whatever the up price was, plus 3 over 1.25 times the down one, so that was a half, if you believe that I can compute this. This was equal to 1.2. And this is what we had last time. So these diverse securities, if you go through the trouble of figuring out what P tilde and Q tilde are, it makes it very easy to price all sorts of other derivatives. Because you just look at the payoff, and the payoff will tell you how many you have to buy of each type. So you can generalize this. You can get this famous formula. So more general. So more general. So more general. So more general, if you have a payoff, more general for any function, f from r into r, so I'll get the payoff f of S0u, you get f of S0d, and you were interested in what is the price out here at time 0. How would you price that? Well, you would, the first thing you would do is you would divide here by 1 plus r, you divide here by 1 plus r. Okay, and then you would buy you would buy, how many would you buy of the op security? You would buy F of S0 U divided by 1 plus R of 80 up. And you would buy F S0D of 1 plus R 80 down. And then you get the initial price, initial derivative price. Well, how much do the 80 up cost? That will be P tilde, because that's what one of them costs. 80 up has price P tilde, 80 down has price Q tilde. So you would have to pay P tilde times F of S0U divided by 1 plus R plus, and then the other one would be Q tilde times F of S0D divided by 1 plus R. So you see, as soon as you figure out what these P tilde and Q tilde are, and now we have formulas for them, it becomes quite easy to price any derivative that you want. You simply just use this formula. And this formula here can be rewritten, because what can we do? I can write this here as what? As an expectation under this set of probabilities P tilde and Q tilde of, and then I'll have 1 plus R in here, and then I'll have F of S1. So this is the risk neutral pricing formula. What is the initial derivative price? It's the expected payoff discounted, but where you use probabilities coming from P tilde and Q tilde.
Why is the risk neutral again here?
Let me ask you a different way. What other probabilities do you want to put there? And these are the only ones we have, right? P tilde and Q tilde, those were the values, those were the initial prices. P tilde and Q tilde were the initial prices of getting 1 in the upstate and 0 in the downstate, as well as getting 0 in the upstate and 1 in the downstate. Right? That's the value at time 0 of getting this payoff at time 1. This here is the value at time 0 of getting this payoff here at time 1. We agree on that?
Right. Okay.
Okay. So then 2 observations. First observation is, what can we say about P tilde and Q tilde? Well, they are the price of getting something positive. Right. So you should be paying something positive for them. Okay. So they have to be positive. What else can you say? Well, if I add them up, I'm getting the constant payoff at time 1. The constant payoff is 1. In this model, what is the value of getting $1 tomorrow? Well, the interest rate.
Oh, it's because you divided everything by 1 plus R. So 1 is actually just nothing like happened.
So P tilde and Q tilde must add up to 1. They must be positive. That means that we can think about them as a set of probabilities. Right? Because what is a probability? A probability is like there are two events, right? So our entire world has two possibilities. So what is the probability measure on that set? Well, it will be something that assigns a number between 0 and 1 to each event. And when you add them up, you should get 1. That's a probability measure. Right? So P tilde and Q tilde, they are probabilities. Okay, so what can we use them for? Well, just as if I added up these two, I would get the constant payoff of 1. I could think about something more general. I could think of a payoff that would be 6.4 and 1.6. Or I could just take an arbitrary function and think about the payoff that would be f of the stock in the up state and f in the stock in the down state. Then I have to switch to the discounted prices because this is where my early securities pay up. So I need to divide by the money market account at time 1. That's 1 plus r. So I do that both states. So I'm interested in the value of a security that has this as its payoff in the up state and has this as its payoff in the down state. Okay, how much are we willing to pay for this payoff? Well, how much are you willing to pay for the payoff in the up state alone? Well, how many units of the first early bird security do I need to buy? Because every time I have one of these, I'm going to get $1 in the up state and $0 in the down state. So how many of these do I need to buy? Well, I just need to buy whatever the payoff is. That's how many units I need. Okay, so I'm buying that number of units in the up state. I'm buying that number of units in the down state. Okay, so what's the price of this thing? Well, I know what the price is of an early bird security because I computed them to be P tilde and Q tilde. So this is going to cost me P tilde times that quantity. This thing here is going to cost me Q tilde times that quantity. So then I add them up to get the portfolio value, and that's what I wrote here. And this expression here, this is exactly the expectation of this particular random variable having here, right? The expectation of a random variable. So this is where your background in probability is going to come in handy, because what is the expectation of a random variable? If I'm looking at the expectation of a function, or should we call it f here, we call it something like g of my random variable psi, well, what is it going to be? Psi can take two values. It can either be u or it can be d. So if I'm computing expectations under p, this is without the tilde, then I'll get the probability that psi is up times g of up plus the probability that psi is down times g at d. This is if I were to compute the probabilities under the p measure, but I'm not interested in that, so I'm putting tildes everywhere. Okay, but I know exactly what this here is. This is my p tilde times g plus q tilde times g of d. So the expectation of a function of a random variable that can take two values is this formula here. Any more questions, comments on this? This thing here has many names, and we already called it something. We called it the risk-neutral pricing measure. It has many names. So it is called risk-neutral. It's also called an equivalent. An equivalent martingale measure. It's also called a pricing measure. So here are at least 3 names for the same object. I'm saying this because different textbooks, different professors, they will call it different things. It all means the same as this measure here. And so it begs the question, like, okay, so pricing measure, I get it. We compute derivative prices using the measure. Okay. But why is it called risk neutral? And why is it called an equivalent martingale measure? So this is not so clear. Let me try to see if I can get it to work. So I had worked out this calculation somewhere. So I see if I can work it out without making too many mistakes. So we get this idea. So let's, so this here is different. This is different than P. This is not the same as that measure P that controls size behavior. And the only assumption we made there was that there is a probability that there's a positive probability that psi is U under that measure, and there's a positive probability that psi is D under that measure. This is not the same as what we have here. So if I am to compute, I get this idea, I want to compute the expectation. I want to compute the expectation of S1 divided by 1 plus R. Right? If I take f here, just to be the function f of x is equal to x, I'll just get S1 or 1 plus R. Okay, so let me compute that probability. And let's work out what this thing here is. So 1 plus R is a constant, he can go outside the expectation. So then we have S1. So the probability of S1, this will be, it'll be P tilde, and then it'll be S0 times U plus, and then it'll be Q tilde times, and then we need the down value, so this is S0 times D. Yeah, that looks like a mess. Let's see if we can work it out. So I'll have S0 out here. Okay, S0 goes out there. I'll have 1 over 1 plus R. Okay, so he goes there. And then I'm going to plug in, I'll plug in P tilde. So we need to figure out what P tilde was. We had it on the sheet somewhere. So P tilde sits here and Q tilde sits over here. I'm going to plug these things in, and you can see U minus D is common in both of them. Okay, so what will we get? We had U is sitting over there, and so we need P tilde. This is 1 plus R minus D divided by U minus D times U plus, and then we have S0 went outside. We have Q tilde is this mess up here is U minus 1 minus R divided by U minus D times D. And so what do we get here? So this is a long mess. It's S0 times 1 over 1 plus R, 1 over U minus D. Okay, so I'll pull that common thing outside. Then what do I have left? I have U plus UR minus UD plus UD minus D minus RD. What do we end up with here? Well, you see two things canceling. This thing and that thing, they cancel each other. And then here I'll have, what will I have here? I have U. So I'll have 1 plus R times U. Here I'll have 1 plus R times D with a minus sign in front. So this is cancelled, this is cancelled, and so we have these two terms, and here I have divided by 1 plus r divided by 1 divided by u minus d. So you see all of this stuff cancels out, and what you're left with is 0.
Is that why it's risk neutral?
That's why it's called risk neutral. Under this crazy set of probabilities that I've myself created, the stock grows at the same rate as the bank, right? So under, I should say here, those of you that spotted it, you could see this was a Q that was coming out here. So every single other textbook I have ever read uses the notation Q for what our book uses the notation for P tilde. So it's like starting to write a function, instead of calling it f of x, try to call your function for x and call the input for f, and see how many mistakes you make. Yeah, has you ever tried that? Like you're used to having f of x, this is equal to e to the x, right? You've seen that a million times, or you see like sine x. Try to swap the notation and see how confusing you can make it. So let's call this for x of f, and this is defined to be e to the f. So your dummy variable becomes f, and the function becomes x. Does anybody believe that this is going to lead to complete confusion on all ends? Right. So this is what happened with our textbook. Every single other textbook calls P tilde for Q, but our textbook calls it for P tilde. Right? So you'll see me write these Qs everywhere, because this is what I've done for years. Anyway, this is just a side comment. This P tilde, I'll try my best to keep writing this P tilde like the textbook likes to do. But it amounts to switching the roles of X and F in your standard calculus textbooks. And nobody would do that, right? Everybody would call the dummy variable for X. Nobody would call the function for X. Right, so under this measure P tilde, the stock grows like the bank. So this is an expectation, right? Why is that? Well, because, so I have E tilde of S1 divided by 1 plus R. This gave me S0. And likewise, this is silly because there's no randomness in the bank, but if I looked at S01 divided by 1 plus R, this would become exactly S00. So the growth rate, the expected return, call it what you want, it's the same under the risk neutral measure. Right, and you will not, people are in general risk averse, right? So you will not, if you had the choice to, here's a security that's gonna grow in expectation with 5%, and here's a bank that has no risk and is gonna grow with 5%, nobody would buy the stock. Right, because we are risk averse, so we would prefer a 5% return that's guaranteed over a 5% return that is, most people would, not all, but most people would prefer security that would pay 5% for sure versus a security that would pay on average 5%. And of course, the prices of these two securities being exactly the same. So this stuff like this is never going to hold under the original measure P that we haven't worked with. This here, this is why it's called a risk neutral measure. It's called a martingale measure. This property here, these are also examples. Examples of a martingale property, which is this is coming up next. Yeah. I think this is a good place to call it quits for the night. As I said early on, I'll try to get these lectures started 10 minutes before or so there can be some time for questions. But if there are questions now, there's also a possibility. So we have a few minutes before it's 8 o'clock. Are there any questions?
Professor?
Yep.
Would it be safe to say that the risk neutral pricing there, it's called such because it takes into account the states when it's going up and down and the interest rate that the bank offers?
Yeah, so I would much rather see this pricing relationship that we had here, this one here. This is coming out of replication. This,
okay.
This initial derivative price here, this comes from a replicating argument. But we're trying to replicate this payoff here by trading in other securities which we already know the price of.
Okay.
Right, and the prices are those securities that these are the broker prices. And we know that we already figured out that the initial prices for those were P tilde and Q tilde. And then it just ends up being that I can recognize this sum here exactly as an expectation.
Oh, okay. That's right.
There is an interview question that asks the students exactly the question that you asked me now. And there's no limit to the amount of frustration that I have seen students have with the interviewer, because the interviewer is asking for you to say some specific buzzwords, and so this can be a huge pitfall. This is one of these screening questions. So I don't know how it functions during the Corona crisis, but it used to be that you would have these screening in phone calls where there'll be somebody from HR and you would do the screening interview. And so they would ask you, tell me what a risk neutral pricing measure is. And then there were like 4 buzzwords you were looking for. And the students would, if you didn't say one of those, that could be the end of the line of interview. So it is a tremendously tricky question to answer to the satisfaction of the people that interview you. Okay, so Steve Shreve, he actually wrote a specific document addressing this exact question. So if nothing else, you could show this document to the interviewer. So I have this document, and it's like a 5-page note, and it answers exactly how Steve Shreve himself would have answered this question. Okay, I'll post it up on Canvas, and then you can all grab it and have a look at it. So to me, replication, this is the key idea. This is the value of the derivative at time 0 because it's the value of the replicating portfolio.
Oh, okay.
And it turns out that that value can be written as an expectation. Obviously, that's why this is true. So this is an expectation. This is true because P tilde and Q tilde sum to 1, they are positive. And so that's how I would answer the question. But I do recognize that there are students that have given answers along these lines, and they've gotten into trouble with people that have interviewed them. I mentioned my wife during the earlier discussion, and she sees one particular example of a student who got screened away because he gave an answer along the lines that I had, and this was not enough for the screener on the phone at that time, and she had no idea what she was doing wrong. So this can be a huge pitfall when you get this question. Yeah, so I'll post a note of Steve. I'm not saying this is a guarantee to get you out of this situation, but I sympathize with your question. This is a non-trivial question to answer to somebody who has no background in quantitative finance. Okay, are there more questions?
I just I'm kind of confused about the construction of the AD security. Are the is the up 1 and down 0? Like, did we just choose? Why do we choose 1 and 0? There's kind of like.
But that's typically
that's just indicating like it went up or went down, or like.
But just think about it. What else would you put here? Would you put 5 and 4? And 4
Okay.
and 5, right?
Okay,
Normally
I guess so. I guess so.
Right. Normally, when you think about basis elements in R2, we prefer to think about our basis elements as the one that have a 0 and a 1, and the opposite.
Okay, so there's a linear algebra perspective.
Yes.
Too.
But it digs
Oh, okay.
deeper.
You have a system of 2 equations, and then.
Yeah.
Okay.
Yeah. I mean, there's nothing that prevents you from thinking about a basis that is not the standard basis. You have seen that in linear algebra too, right? There's something about eigenvectors and eigenvalues that play a role, and you can find a basis that consists of such eigenvectors, and that might be important for other purposes. But normally we prefer to think about basis elements as simple as possible, and there's nothing simpler than zeros and then a single one. So that is what we're seeing here, right? If we were to have that model from last time where we had 3 states, if we were to have a trinomial model, right, then you would have 3 branches. So you'd have 1, 0, 0, you would have 0, 1, 0, and then you would have 0, 0, 1. Right, so then you have 3 erodible securities. You have 3 ADs.
Right, but in that case, what we said was there might not be enough equations.
So then we need more stocks.
I see.
You need more stocks. You need 2 stocks and 1 bank.
I have a question on the page that you were just on with the creating AeroJubro securities.
Yep.
Okay, so you have written for P tilde and Q tilde that they equal the delta naught plus the delta times 4.
Yeah.
Is that equivalent to the 1 plus R minus D over U minus D, or is this something different now?
We had the same. That's the same. Because this is how we found P tilde in the first place. This was page 7. Let's go back to page 5. Right, so these equations here, these should be the same. I can get them to work, right? These equations that you see here, and these are the ones you see here, and these are the same.
So like if I was to plug in the negative D over U minus D for the delta naught, and then the 1 plus R over U minus D for delta, and then multiply that by 4, I should end up with the P tilde of 1 plus R minus D over U minus D.
You need to trade. Keep in mind we had normalized. We had tricked a little bit. We had normalized the stock price here to be 1.
Oh, okay. Thank you.
So then you need this one here will be fine, but you need to have an S0 in these places here. Or you could go over here and get rid of this 4 here and just put a what would you have? So you have to normalize the starting point to be 1. So then you go from 1 and then up to 2 and then down to a half. We could also do that.
Right. Okay. I forgot the normalization. Thank you.
Yeah. Right. Alrighty, guys. My stomach is starting to rumble. it's dinner time. I want to remind everybody that we do have office hours tomorrow morning. This is a set of joint office hours with another class, but it's the same material so far, so it's not a big difference. It's from 10 to 11, and then the first homework is due tomorrow night at midnight on Canvas. This is that there are typically problems with submitting these homeworks on Canvas, at least in the beginning. So if and when you run into problems with this Canvas submission site, just let me know, and we'll try to get it to work. I set it up such that you should have more than one attempt to try to upload. So if you change your mind, you can upload a new version. But I from based on Sakai experiences here in the beginning, there always seems to be some mishaps with this stuff. So if and when that happens, we will try to straighten it out over the weekend. Okay. If nothing else, then have a good night, guys, and I will hopefully see some of you tomorrow morning. Otherwise, I'll see all of you on Tuesday.
Thanks, Professor.
Thank you.
Thank you.
Bye.
Thank you.